Okay, today we're going to do a little bit of a review of some stuff that we learned in a previous unit. So today we're going to do multiple representations of linear relationships. To start out with, I just want to remind you that whenever we're working with linear relationships, it's always going to be in the form y equals mx plus b. Okay, we know that m stands for our slope. Okay, m stands for slope, and the way that I want to help y'all remember this is that slope always goes next to x. X is married to m, and m is what happens multiple times. Okay, so you can remember that married and multiple both start with m, so I know x is what happens multiple times, and it is going to go right next to my slope. Okay, the other letter that's up there is b. B is where it begins. Okay, B is where it begins, or it's where it happens one time. Okay, if something only happens once, it's not going to be multiple times. It's not going to be m or x. It's going to be our B. It's going to be our starting value. That's my y-intercept. Okay, so let's look at this first one. The verbal description says that David is buying movie tickets online. There's a processing fee of $5, and each movie ticket is $10. Okay, so the first thing is whenever you go to the movie theater and you purchase something online, they might attach a fee because you used online instead of going in person to buy it. They start out with a $5 fee. Now that's only going to happen one time. He can order multiple tickets, but the fee is only going to attach one time for the one time he used it online. So this is happening once. And no matter how many tickets he buys, he's going to have to pay that fee. So this is also my B, because it's where it begins. So I know that this is letter B. Okay, then I have that each time that he buys a movie ticket, it's going to cost him $10. Okay, that word each is really important. When I see the word each, that tells me multiplication. It also tells me x. Okay, and I know that m is married to x. So I know that next to my x is where I'm going to put m, which is my $10. That's my slope. Okay, it's going to happen multiple times each time he buys the ticket. Now that I have all of that information from the word problem, I can write my equation. So over here in this box where it says equation, I know that it's going to start with y equals. Then I need to write my slope. That's what happens multiple times. That's the cost of the ticket. Okay, it's $10 for a ticket. M is married to X, so I know that I need an X right there next to it. And then I'm going to add my B to the end. My B is where I begin. It's the value that only happens once, and in this case, it's 5. Now that I have an equation, I can fill out a table. So down here, if I purchase 0 tickets, okay, tickets is my X value, because remember, each was my movie ticket, it's married to X, the cost, so I know that tickets is going to be my X value, and cost is going to be my Y in the table. I can plug this into the equation that I wrote, so I have Y equals 10 times 0 plus 5. 10 times 0 is just 0, and then I add 5, that means that it's going to cost me $5. Okay, so even if he didn't buy tickets, but he went online, that doesn't make a ton of sense. Okay, you would think that if he's not going to buy any tickets. Okay, but just for the sake of this question, just for the sake of this situation, we're going to say that it goes ahead and charges him $5 just for logging in online. Okay, if he bought one ticket, I'm going to do the same thing, plug it in. I have y equals 10 times 1 plus 5. 10 times 1 is 10 plus 5 would give me 15. So if he buys one ticket online, it'll cost him $15. I'm going to do this for the entire table. So I have y equals 10 times 2 plus 5. 10 times 2 is 20, plus 5 would give me 25. For 3 tickets, y equals 10 times 3 plus 5. 10 times 3 is 30, plus 5 is 35. And for 4, I have y equals 10 times 4 plus 5. 10 times 4 is 40, plus 5 is 45. Now that I have my entire table filled out, I can look at my graph. Okay, they already put the graph line on there, but I'm just going to go ahead and check it, make sure that it's correct and that I understand it. So for 0 tickets, he still had paid the processing fee, which was $5. For 1 ticket, he paid the processing fee of $5 plus 10 for the ticket. That gave me 15. For 2 tickets, he paid the processing fee of $5 plus $20, which gave me 25. And so on. Okay, so my graph is correct. They already graphed it for me. That was very nice. Looking at the next problem, my verbal description says a person starts out with 18 tickets at a carnival. Each ride is 2 tickets each. Okay? So what this is telling me is that I'm starting out, or I'm beginning with 18 tickets. So I know that 18 is my B. It's where I begin. The word each tells me that I'm going to multiply or that I have X amount of something. My slope is married to X, so I know that the number that comes next is going to be my slope. It's happening multiple times. I can ride multiple rides at the carnival. Now, something important about this is if I'm starting with 18 tickets and I'm losing 2 tickets every time I get on a ride, my slope is not going to be positive. I'm not gaining tickets by riding the rides. Instead, I'm paying for them with the tickets. I'm losing tickets, so it has to be negative. So I know that my slope is going to be negative. Now that I have that information, I can write my equations. I know it's going to start with y equals. My slope, we said, was 2, but we said I'm losing 2 tickets, so I know it's going to be negative. My slope is always married to x. And then I'm going to add on my B value, my initial value of 18 tickets. That's how many I started with in my pocket. Now that I have an equation, I can fill out my table. So coming down to our table, 0 tickets, I can plug in for x. So I have y equals negative 2 times 0 plus 18. Anything times 0 is just 0, so I just have the plus 18. I didn't ride any rides, so I didn't lose any tickets. I still have the ones I started with. If I go and I ride 2 rides, I have y equals negative 2 times 2 plus 18. Negative 2 times 2 is negative 4. Remember, when you have a negative times a positive, it's still negative. So negative 4 plus 18, or 18 minus 4, that gives me 14 tickets. And I'm going to do this all the way down my table. So I have y equals negative 2 times 4 plus 18. Negative 2 times 4 is negative 8. Negative 8 plus 18 would be 10. Then I have y equals negative 2 times 6 plus 18. Negative 2 times 6 would be negative 12. Plus 18 would be 6. And for my last one, I would have y equals negative 2 times 8 plus 18. Negative 2 times 8 would be negative 16, plus 18 would be 2. Now again, they already filled in my graph over here, but I'm just going to check it and make sure I understand. So for 0 tickets, I didn't spend any, so I still have what I started with, which was 18. If I ride 2 rides, I'm going to lose 4 tickets, so I'm down to 14. 3 rides, I'm losing, if I plugged in 3 for x, 3 times -2 would be -6, plus 18 would be 12. Okay, so even though that wasn't in my table, I can still check it on my graph and see that it's correct. Okay, just make sure that you understand that graph. Make sure that you understand how to put a word problem into an equation. If you don't, let Ms. Hodge know so that I can help you. Flipping to the back of this paper, this one's talking about functions. A couple of things about functions is that on functions, I know that my x value never repeats. Another thing that I know is that it has to pass the vertical line test. I'm going to abbreviate that as VLT, vertical line test. What this means is on a graph, okay, I have a coordinate graph here, I should be able to draw a bunch of vertical lines, and it should only touch my graph one time. So let's say that I had a U. These lines only touch my U one time for every line that I draw. Okay, it has to pass the vertical line test. So let's look at a couple of examples. My first one says that the graph shows y as a function of x, which ordered pair could also belong to the function, and they want us to select 2 correct answers. Okay, so remember, my x values can never repeat. So if I go to -4, 3, -4, I'm going to count over 4, 1, 2, 3, 4, and then up 3, 1, 2, 3. If I plot this on this line here, and then I drew a vertical line, it's going to touch both of these points because they both have an x value of -4. So I know that cannot be a function. If I go to -2, 1, 2, and then up 3, 1, 2, 3, and I plot a point, I want to check to make sure there's not any other x values that that's going to touch. If I draw a line down that x value, it only touches that one dot. So I know that that is a function. I'm going to go ahead and put a filled in square because I know that that is one of my 2 correct answers. I'm going to keep checking. So if I did 0, -1, I'd go to 0 and down 1. If I plot a point there and then I check to see if there's any other x values there, there sure is. That line's going to touch 2 points, so it cannot be a function. If I do 4, -4, 1, 2, 3, 4, 1, 2, 3, 4, and I plot a point, and then I check to make sure there's not any on that line, there is one on that line. It's going to touch in 2 points. It cannot be a function if it touches more than once. So I can mark that one out as well. Then I want to check 3, -2. I count over 3, 1, 2, 3, and down 2. Plot my point, check my x's. If I draw a line, it touches at 2 points. That cannot be a function. I'm marking that answer choice out. I know that means my last one has to be a correct answer, but let's go ahead and check it. I go to +2, 1, 2, and then up 3, 1, 2, 3, plot my point. I need to check, are there any other dots that fall on that x value? There is not. It touches one time. That means it is a function. Okay, I want you to look at number 8. It says, which of the relationships shown represents y as a function of x? This one gives me some graphs that already put the lines on there for me, so I'm going to run the vertical line test. I want you to draw a vertical line somewhere across that graph. On this first one, I want you to write or mark where it touches that line. Okay, so I have this sideways V. It's going to touch the line I drew 2 times. If it touches more than once, then it is not a function because functions only touch once. Okay, so this one touches 1, 2 times. It is not a function. On the next one, I can draw a line. This one is a vertical V. I'm going to make a dot where it touches my graph. This one only touches one time. Now I'm going to draw a couple more lines to make sure that this truly is a function. No matter where I draw a line on this image, it's only going to touch it one time. Okay? If it only touches one time, then I know it is a function. Okay, we're going to look at number 9. It says which graph represents y as a function of x. Again, it gives me some graphs so I know I can perform my vertical line test. On this first one here, the line that it shows me is going straight up and down. If I draw a line straight over that one, it is going to touch it at every single point on that line. It is touching a ton of times because it's laying straight on it flat. Okay? Because it touches a bunch of times, it cannot be a function. The next one is a triangle. If I draw a line somewhere on that graph, and then mark how many times it touches that line. For this line that I drew, it touches it twice. Because it touches twice and that's more than once, this is not a function. Looking at B, if I draw a line on that graph, and then I put dots where it touches it, it's touching it twice where I drew my line. That cannot be a function. The last one has a horizontal line. It's going straight left to right. If I draw a vertical line over that, it's only going to touch it once. Okay, make sure that when you're doing this that you're really careful to use the line that they graphed and not the coordinate grid, okay? Your coordinate grid is your x and y axis. That is not part of the actual graph that they drew. The only part of the graph that they actually drew is the black line above. Okay, just be careful about that, be cautious about that. I want you to try number 10 on your own. Okay, when you turn in my paper, I'm going to check to make sure you have it completed. Same thing with number 7, it's just like the one above that we did. You're going to check, make sure that none of your x values repeat. So looking at your x values and the answer choices, you should find 2 correct answer choices. Okay, we're going to look at number 8 together. So this one says, which of the relations shown represents y as a function of x? Select the correct answer. Okay, again, your x values cannot repeat. So if I'm looking at this table, I only want to look at my x values. I have 1.4, 2.2, negative 1.4, and negative 2.2. None of those repeated. Okay, a positive 1.4 is different than a negative 1.4. Because it's positive and negative, they are not the same number, so those numbers do not repeat. So this is a function since there are no repeats. On the next one, I have a map. It's telling me that the x value 11 goes to both number 11 and number 13. If it goes 2 different numbers, if I wrote these as ordered pairs, that would be 11, 11, and 11, 13. Those have the same x value. That is bad, okay? Functions never have the same x value. So I know that this is not a function. Then on the last one, it gives me ordered pairs. Again, I only care about my x value, so I'm going to look at all of my x values. That's the number that comes first in an ordered pair. Remember, ordered pairs are always x, y. I'm going to check to see if any of those repeated. So I have 3, 9, 4, and 5. None of those are the same number, so none of them repeated. I know that that means it is a function. Make sure that you complete these notes, turn them into Ms. Hodge, have your name on it, and if you have any questions, let me know so that we can go over it, we can talk about it.